In this example, we will learn about the even and odd identities. In Part A, explain what is meant by the terms even function and odd function. An even function is a function that satisfies the condition f of negative x equals f of x. In other words, the y value of the function is the same for any real number and its opposite. For example, f of x equals x squared is an even function since f at 2 equals f at negative 2, which is equal to 4. Even functions are symmetric about the y-axis. An odd function is a function that satisfies the condition f of negative x equals negative f of x. In other words, the y value of the function has opposite signs for any real number and its opposite. For example, f of x equals x cubed is an odd function since f at 2 equals 8 and f at negative 2 equals negative 8. Odd functions have a rotational symmetry of 180 degrees. Now we'll move on to Part B. Explain how the even and odd identities work. Reference the unit circle or trigonometric graphs in your answer. We'll begin by explaining sine of negative x equals negative sine x. Consider sine at pi over 4 and sine at negative pi over 4. The y values of opposite signs. On the graph, the sine values of opposite signs. Also, since y equals sine x is odd, there is rotational symmetry of 180 degrees. Now we'll explain cos of negative x equals cos x. Consider cos at pi over 4 and cos at negative pi over 4. The x values are the same sign. On the graph, the cosine values have the same sign. Also, since y equals cos x is even, there is symmetry across the y-axis. Now we'll explain tan of negative x equals negative tan x. Consider tan at pi over 4 and tan at negative pi over 4. The values of opposite signs. On the graph, the tan values of opposite signs. Also, since y equals tan x is odd, there is rotational symmetry of 180 degrees. In Part C, prove the three even and odd identities algebraically. We'll begin by proving that sine of negative x equals negative sine x. Rewrite negative x as 0 minus x. Expand using the sign difference identity. Sine at 0 equals 0 and cos at 0 equals 1. This simplifies to negative sine x. The left side equals the right side, completing the proof. Now we'll prove that cosine negative x equals cos x. Rewrite negative x as 0 minus x. Expand using the cosine difference identity. Cos at 0 equals 1, and sine at 0 equals 0. This simplifies to cos x. The left side equals the right side, completing the proof. Now we'll prove that tan of negative x equals negative tan x. Rewrite tan of negative x as sine of negative x over cos of negative x. Use the even and odd identities to get negative sine x over cos x. This becomes negative tan x. The left side equals the right side, completing the proof.